Hi, I'm Mark Mitchell with Blue Valley Technologies. My entry for Microsoft's Dare to Dream Different challenge is the Energy Stat. The goal for the Energy Stat is to create the world's most energy-efficient thermostat. To help demonstrate the Energy Stat, I've built a small-scale model home. Devices illuminate when active to indicate usage. This home implements a gas furnace, central air conditioner, and a geothermal heating and cooling system. I've built the model to closely duplicate an actual heating and cooling system. A 24-volt AC transformer provides power, and all components interconnect using common 7-conductor thermostat wire. Positive air circulation is represented by the fan, while a pump circulates fluid through the geothermal tubing system. I've also added 2 sliding dimmer switches here, next to the Energy Stat. They have been modified to simulate various sensors for this demonstration. This slider simulates changes in the indoor temperature, while this one is currently set to simulate the air temperature outdoors. The single biggest factor in how much energy is used in any heating or cooling system is how it is used. Whether your equipment is ultra efficient or quite the opposite, energy consumption and consequently utility savings can both be improved simply by altering the comfort settings. The Energy Stat recognizes this and encourages the user to keep their thermostat set at an efficient setting. The Energy Stat is constantly calculating the estimated daily cost based on its current settings and external factors, such as the current outdoor temperature and UV index. As the Energy Stat learns the characteristics of your home, it gives an increasingly accurate prediction of your energy costs. When you change a setting, such as desired indoor temperature, you will immediately see the impact of the setting on your energy usage. This will encourage people to keep their settings at reasonable values. The desired temperature is controlled by a graphical slider. Since this is typically adjusted only a few degrees at a time, tapping on either side of the indicator will advance the setting 1 degree per tap. Larger adjustments can also be made by pushing directly on the slider button and then dragging your finger to the desired temperature. Additional settings may also influence the estimated cost per day, factors such as running the circulation fan all the time. This can be demonstrated easily. As you can see, the estimated energy cost for my model home went up after I enabled the fan to run all the time. By continually giving this feedback, the users can experiment with different settings to discover what the most efficient settings are for their own home, while still meeting their personal comfort preferences. In order to accurately measure and learn your home's characteristics, the Energy Stat requires a lot of information. The current weather conditions can play a large role in the temperature of your home. The Energy Stat is capable of using an internet connection to retrieve the current weather conditions based on your zip code. Since the Energy Stat uses this information, it made sense to display some of this info for the user as well. Currently, it is displaying the outdoor temperature, wind speed, humidity, as well as the forecasted high and low for the day. Oftentimes, when a home has alternative energy heating and cooling devices, the older equipment can remain intact. Typical thermostats usually cannot be connected to multiple devices, and those that can only use the device that you have selected. The Energy Stat is the only thermostat that will learn and profile the efficiency of multiple heating and cooling devices, and then decide which is the most suitable to use in the current conditions. In some circumstances, traditional energy equipment can actually be more energy efficient. This is usually in times of extreme heat or cold, where some of the alternative energy devices will struggle to keep up with the outside temperature influences. The Energy Stat is continually monitoring devices' efficiency, even as it changes over time. This can give the user an advance indication that a device has lost efficiency. This could be due to a component failing, or even simply due to a clogged air filter that just needs changed. The sooner a user is aware that their efficiency has dropped, the sooner they can investigate the cause and correct the problem. This alone could lead to substantial energy savings, as the user might otherwise not have been aware of the problem. Since the Energy Stat does have internet connectivity, there is also a Silverlight-powered remote access interface. The Silverlight application enables users the convenience of programming or adjusting their thermostat from their web browser. Not only is this convenient, this can also lead to additional energy savings. For example, consider a traveling sales executive that had to make a last-minute business trip. The temperature setting at the home could be adjusted to a more economical setting right from the hotel. It also adds the ability for a vacation homeowner to adjust the destination home's temperature to a comfortable setting just a few hours before they arrive. Alerts could be set up as well, so that the Energy Stat can send an email or text message in the event of an equipment failure or an extreme temperature. This can offer peace of mind. For example, owners of pets that are sensitive to extreme temperatures, or for vacation homeowners, possibly averting major damage from frozen pipes. The prototype core is a Meridian-based Tahoe 2 from Device Solutions. This board is running version 3.0 of the Microsoft .NET Micro Framework. Using the development board allowed a nice base for prototyping of this project, since many fundamental requirements, such as the network interface, color LCD screen, and touch controller were already present. Expanding from the Tahoe 2 board, I have added several additional components. An additional requirement was the Energy Stat will need several outputs to control the various heating and cooling devices that it is connected to. I've designed the Energy Stat to easily support 8 outputs for this competition. This design is modular, based around 3 general-purpose output pins from the Tahoe interfaced with a shift register chain. You can see the bank of relays here on my project. I have also added an LED to indicate the current status of each relay output. Because the Meridian CPU will lose the time if it is reset, I've added an I2C bus controlled and battery-backed real-time clock. The clock IC is here, along with its quartz crystal here, and the backup battery here. The Energy Stat also needs to interface with a variety of sensors so that it can learn the characteristics of the home and its equipment. To accomplish this, I've added a dedicated analog to digital converter. This particular IC allows monitoring of up to 8 separate analog inputs. The analog to digital converter is also controlled using the I2C bus. Although the Energy Stat will cost more than a typical thermostat, many consumers have already demonstrated that they are willing to pay a little more for something that helps reduce their reliance on fossil fuels. I plan to market the Energy Stat by demonstrating that the combination of high-quality components, the substantial energy savings, and the luxurious features can create an unbeatable value. I also hope to offer additional accessories that, when combined with the Energy Stat, provide additional functionality. Home automation, for example, is one area where the Energy Stat could become the central controller for an entire home automation solution. Other possibilities include additional energy monitoring. For example, adding a sensor that measures the total home electrical usage. By giving the homeowner the same visual, immediate feedback for total electrical usage, it could encourage the homeowner to reduce their energy consumption in all aspects of their home. Another option I will consider is to offer a subscription-based monitoring service. The Energy Stat would include the service for free for a period of time, after which a very small renewal fee would apply. This may allow for lower initial purchase costs of the Energy Stat, since the subscription revenue could help offset the hardware and production costs. The service would not be required for the core functions of the Energy Stat. Instead, it would provide optional features such as the remote access interface or email and text message alerts. This method could provide a slightly more consistent and stable revenue. I was very pleased with the speed that this project could be developed. I have never before had the object-oriented power of .NET at an embedded level. This has assisted greatly in enabling the Energy Stat to have an intuitive graphical interface and for calculating the complex physics needed for learning the thermodynamics of the household and its devices. It is very easy to fall into the trap of missing some of the objects from the full .NET framework. However, when compared to the very limited language support from any of the past embedded projects that I have worked on, there is simply no comparison. I found the included .NET Micro libraries to be adequate and was able to easily duplicate any additional .NET functionality that I needed. As for improvements, some additional control for performance tweaking would be nice, as well as more reliable access for saving data to the flash memory.